Design patterns are often classified into three categories. These three categories are behavioral, structural, and creational. Let's take a brief look at what these three categories are and what common characteristics patterns within these categories share. Let's talk about creational patterns first because they are clearly different from the other two categories in their reason for existence. As their name would give away, creational patterns relate to how objects are constructed. They typically seek to decouple the construction of an object from its use. Why might that be? There are a number of possible reasons why one might want to decouple the construction of an object from its use. One possible reason, we might want to hide the implementation of an object and only really reveal its interface, i.e. how it ought to be used. Another possible reason, we might want to defer instantiation of the object until runtime. In other words, we'd like to leave until the very last possible minute the choice of exactly which object is going to be created. It's also possible that we have families of related objects that only make sense when they are used together. And yet another use for separation of construction of an object from its actual use would be to restrict the creation. Say we only want an object to be created once or once per unique value. In either one of these cases, we would use creational design patterns. It turns out that every one of the possible use cases that I have enumerated so far specifically is implemented or is used in one or more design patterns. As an example, take the last one. If you would like to allow the creation of only a single instance of a class, then it's the singleton that we are discussing. If you would only like to have one object per unique value in a sense, then it's the flyweight pattern that you would be talking about. Creational patterns are an important category of design patterns, and that's because all of these patterns share this common characteristic. They explicitly seek to decouple the construction or the creation of an object from the way that object is used. Next, let's talk about behavioral and structural design patterns kind of at the same time. That's because these categories are very easy to conceptually mix up. It's very often the case that it's not clear what exactly the difference is between these two types. So let's juxtapose them and talk about them simultaneously. I am explicitly going to give out 2 or 3 different ways of thinking about these two categories, and you are at liberty to pick whichever of these helps you understand the difference between these two the best. One way that I have often found helpful of imagining the difference is as follows. Behavioral design patterns talk about how objects of a class behave or interact with each other. Structural design patterns talk about how classes behave and how they are related to each other. That's one way of thinking about it. This works for me. Maybe it doesn't work for you. So let me go ahead and repeat this in a slightly different way. Virtually every design pattern relates to how some entities are set up. These entities are usually classes. Let's take the set of all these entities and let's call that set a logical unit, because that's what that set is. It's a set of classes, all of which are governed by an underlying design pattern. Okay, now if the design pattern governs how that logical unit as a whole interacts with the outside world, it's a behavioral pattern. If that pattern governs how individual elements within the logical unit interact with each other, then it's a structural pattern. In a sense, behavioral patterns are all about the interface which this logical unit provides to the outside world, the skin or the surface. Structural design patterns are about the guts, the implementation of that logical unit as a whole. Again, the logical unit need not be a single class. It in fact usually would be a set of entities, i.e. a set of classes. Let's try and make this a little more real with an example. Let's consider the iterator pattern. Now I know we've yet to talk about this pattern, but this basically is a way in which we access every element in a collections class. The logical unit in this instance is just one class, that's the iterator class. Now this pattern basically governs how the iterator is used by the client, i.e. the outside world. It is also possible for the iterator pattern to govern the interaction between the iterator and the collections class. That's possible also. But in any case, the pattern governs the logical unit, which is the iterator class, and the way in which it interacts with the outside world, either the user or the collection over which that iterator iterates. Thus, what is defined by the design pattern is the behavior of the logical unit, and that's why the iterator pattern is a behavioral design pattern. Now let's by contrast consider a different design pattern, which is the model view controller paradigm. Here, the logical unit, which is defined by the pattern or the paradigm, consists of three classes: the model, the view, and the controller. And the paradigm or the pattern governs how the model, the view, and the controller interact with each other. In a sense, what the design pattern defines is the structure of the logical unit. And that's why the MVC paradigm is referred to as a structural pattern. And it's also pretty clear that this is not a behavioral pattern, because the model view controller paradigm does not change the way the user interface behaves or how it relates to the outside world. You might switch out the model view controller and use some different user interface techniques to wire together the elements of the user interface. The behavior of the user interface would not change. And that's why it's clear the model view controller paradigm is not a behavioral design pattern.